Hey, good morning, good evening, good afternoon, everyone. Thank you for joining this 2-hour live workshop. Today we will talk about Apache Pulsar. Uh, I might say Pulsar with my ugly French accents, Please, please do not kill me. And Apache Cassandra. So it's a live workshop. Um, you know me, maybe you see me every week. We are there every week, same time, same YouTube channel. I'm leading the developer advocacy team at DataStax. I'm doing a lot of Cassandra, coding in Java, doing a bunch of APIs. You see my coordinates on the top right-hand corner of the screen. Please invite me in your network. Would be happy to have you. But today, the guest star, the big speaker is David.
Oh
Hello,
no.
David.
Oh no, don't do that. And by the way, we don't even need to put your slide up there. You're right. Like everybody knows Cedric. So it's already done. Hey everybody, I'm David Diroff. I am a streaming developer advocate, which means I have a particular affinity towards Apache Pulsar. I am bringing a Kentucky accent, and so the French accent and the Kentucky accent, we're gonna have fun time today.
Oh man, what a combo. But stay with us. I mean, the session will be great, okay? It's not only me and David on screen. We have people helping us to build the content, to host the session, to answer your question on YouTube and on Discord. Here is the team, and we are distributed across the world, as you might see. It's a live session, so very few housekeeping. We are live on YouTube, also probably on Twitch as a backup stream, but we are not really monitoring the chat there. So stay with us in the YouTube chat for better interactivity. If you have questions when you watch the recording, you can still go to Discord. Here is the link. And because it's an interactive session, you will do exercise, you will do hands-on. We will also ask you questions and do some quiz all together. And if you pay attention and answer the questions correctly at the end of the session, we will redeem some swags. So stay tuned, stay up to the end for all together play a game and you to win some swag. So
There
it's a
is
work.
homework.
Yeah, yep. They are homeworks. It's not a webinar. Okay, sorry, it's not a marketing webinar. It's a technical workshop, folks. So today you will see a lot of code. We will actually implement something all together in 2 hours. And the good part, you don't have to install anything. Everything's provided to you on GitHub repo. You can use !GitHub on the YouTube chat to get the links. It's also in the description below, all the link that you will need today. You don't have to install anything. It's all web-based. We are using an IDE in the cloud called Gitpod. It's VS Code in the cloud, simply put. And for the databases and the Pulsar streaming platform, we will, with the M typo, we will use also something web-based. Okay, so cloud service for Pulsar as well. Okay. If you have any question, please use the chat. As I said, Rags, Mary, probably Aaron also helping answering the question right now. Okay, so what should we do today? I don't know. Let's start with this kind of quiz. I told you it will be interactive. So right now, let's go. Open a new tab or use your phone, okay? And enter the code that's written on the screen. It's still not yet the quiz. I just will ask you questions for you to get your first touch on Menti tool and ask you a few questions. You will see, we'll be cool. We will see where are you from and who's watching the stream with us today. Okay, so the code is on the screen. You can also use your phone and scan the QR code. But hey, yeah, please go. Yep, and as you will see, it's interactive. So menti.com and enter the code or use the QR code. Okay, the QR code is also now in the YouTube chat if you want to copy paste. As developers, we want you to copy paste, right? And today you will copy paste a lot, I can tell you that. Okay, so let's see. First question I do have for you. Where in the world are you from? So see, we can immediately see, so people from the US, India, so cool. So Turkish, Greece,
Wow,
and this
cool.
is, yeah, this is how you know how good we are in geography, right? Yeah, Argentina. So that's great. So people in APAC region, double thank you for coming. It might be late for you. We will try to stay on time. Maybe we will shift by 10 minutes, probably no more. And if we cannot cover all the content, we will probably stop, do the game, and for you to go to bed not too late. Okay, so let's see. Woo! Okay, all right. 13 people only in Menti. Oh, okay, okay. You will still have time to join us later. How many are we on YouTube right now? Let's see, let's see. How many folks are in YouTube right now? Oh, 24. Okay, okay. Not bad. Half are with us in Menti. So what is your role as a developer? Are you front-end, back-end, back-end data, cloud native, operator DB, others?
Am I
Back-end,
allowed to answer these?
yeah.
Or do I skew it?
Okay, let's see. All right, look at that. It's pretty evenly distributed. So cool. Oh, cloud native developer. Yeah, I know. I know you, Rags. I know it's you. Admit. Okay, keep moving. Yeah, it's really nice, but we can go quickly over that. It's just for you to get a first touch over Menti again, but we will move into content very fast. Okay. Oh, Python. Perfect, because everything is written in Python today. I'm a Java guy, so I can do the live translation almost, but yeah, everything will be in Python today. TypeScript, C#, Java. Woohoo. Come on, Java guy, keep eating Java. We need to show up and see that Java is still the most used language.
I'm surprised that well, counting myself, there's a total of 2 people interested in C# here. That's like over the top.
I mean, maybe you have two brothers open.
Maybe.
Okay, all right. Thank you very much. So objective for today's commitment to workshop. So we'd like to learn about streaming, Pulsar, Curiosity, or repeat workshop attendee. As I told you in the beginning, we are there every week, same time, still live, same format, 2 heads talking on screen and you doing all the exercises. Okay, right. Repeat workshop attendee. Oh, come on. Are we doing such a bad job that nobody come back? Okay, anyway, please, if you like the format, consider to subscribe at the end, or I like the stream. Okay. Do you know streaming already? If you're already an expert, we can skip the basics. Total beginner. Okay, right. Okay, it's expected. Okay, so we will really go back to what is streaming, what you could expect from Pulsar. Okay, all right. 10 minutes in, I think. Oh, have you been to any of our workshop before? This is the last question for the beginning, but I would expect everybody would say no because, oh, yes. Oh, so maybe to the previous question.
Yeah, there weren't any repeats, so it should be no.
Okay, nice. Oh, yeah, look at that. So now, hey, see? So, oh, I'm relieved. We are not doing such a bad job. You tend to come back. Okay, so right. I don't want that housekeeping just to take too much time. 10, 12 minutes in, let's go into the content. Okay, so thank you. Keep this tab open. We will come back there at the end to play the game. But as of now, I think we can go into the content. So what is Pulsar? a little bit of data science in event streaming, then Pulsar function, Pulsar IO going into Cassandra DB. Okay, so yeah, and with that, I think I will hand over to you, David. So I don't know if you want to share, or I can just move the slide.
No, you drive.
All right, okay, let's get running.
It's probably a little bit easier. So, hey everybody, let's start off just talking about well, event streaming. And when you use the word streaming, there's a lot of other words that are kind of generalized around. We see message streaming, messaging, queuing, all kinds of different words that are passed around. We tend to use the phrase message streaming. I'm sorry, we tend to use the phrase event streaming. That seems to capture a lot of what Pulsar and ASTRA can do. But basically, you're watching for events in a system, right? You're watching for things to happen. Messages are published and they're received. They're usually referred to as an event. Messages, or the data within the message is made available, other systems could make decisions on that using functions, using stream processing, all kinds of different fun things there. And then we're expecting that the messages could be ingested at a very, very high frequency with very low latency. And if you want to get into numbers here, I'm talking about, messages that are, let's say, a few kilobytes, and they're able to be processed in under 10 milliseconds. That's the kind of numbers that we're thinking about here. That's what our ASTRA streaming platform can run on, and also an Apache Pulsar installation. That's the expectation of Apache Pulsar. Do that.
Nice.
Okay.
Okay, let's go.
So this is an interesting one, and this slide diagram kind of came about because we've discovered that there are a lot of misunderstandings of when we say streaming, and when we say like real-time streaming, there's a bit of a misunderstanding. And the difference is, look at the bottom one, not streaming. So you ingest the data, it's persisted to a database, right? So there's your microservices persisting to a database. Then something else is selecting out of the database and you're processing it, probably in another microservice. That's persisting to maybe another table, same database, and then being selected again, right? There's a lot of overhead here. And when you start introducing real time and you need to run at, single digit millisecond times, this is not going to work for you, or you're going to be spending a lot in the cloud to accomplish this. Streaming, the one up top there, that's what we're talking about. A messaging system can do this, but the idea is we can't persist it. We need to work with it in memory, just constantly in memory. At some point it will get persisted, but that's more of an asynchronous, like background kind of task that's happening. We don't really care about it getting persisted necessarily. So you ingest the data, you process it right in memory, then maybe you sync it to a store, and then from that store, other things are selecting the data out, right? This is going to be a heck of a lot faster. And now we can get into real time and talk about some real latency numbers. So Pulsar, just a moment to introduce you to Pulsar if you haven't seen the project yet. Pulsar is open source. Obviously, it's in the Apache Foundation. The real notable thing here is its design, right? And really the thing that sets it apart from what everybody knows is Kafka. The real distinction here is the cloud native design is it specifically has a separate broker, which is stateless, sessionless, stateless, however you want to put it, and the storage, which means to get to those single digit latencies, you can expand the broker, the instances of the broker out horizontally and not have to expand your storage out, right? And so that really gets you in control of your cloud costs and your design, and thus, the whole cloud native thing is being able to horizontally scale individual components. The multi-tenancy in here, so I can run one Pulsar cluster and have many different teams or individuals accessing things, but keep the separation between them the security between them. Many different clients for being able to interact with Pulsar. Java, Pulsar is written in Java, C#, Python, Go, Node, all kinds of fun ways that you can interact with Pulsar. The guaranteed message delivery, I won't go too far here, but there are some very specific things that Pulsar does to guarantee message delivery, and it's actually quite nice. The serverless functions, we're actually going to see some of that, the functions going, and then the tier storage offloads. We're not going to get into that too much here, but what I said before about asynchronously in the background storing the information, right, but not really making that a part of the processing pipeline, that's where the tier storage comes in. It just happens. Pulsar just does it because you've configured it that way to go to S3 or something like that, but you don't actually make any programmatic decisions to do that for it. It's very cool.
Yeah, cool. Yep. No, not much about the tier storage today, but still in 2 hours, you will have plenty of stuff to do.
Yes. So the distributed architecture here, like I said, it's a very cloud native design as far as being able to scale. It's cool because, you know, as you go into production with a Pulsar cluster, you can put some very simple, clear scaling rules, scaling out and scaling in rules on the brokers. And you can put, this is kind of the scary part, you can put scaling out rules on your bookkeepers, which is the storage for Apache Pulsar. Scaling in for your bookkeepers, that's a bit of a tricky thing. But the nice thing is, you know, on surges and things like that, in an Apache Pulsar cluster, you can handle them pretty darn well. Back to that whole cloud native design. The multi-tenancy we talked on, the geo-replication, we're not going to get into that too much today, but you can run multiple Pulsar clusters across like multiple clouds or multiple data centers and have the message replicated across. Pulsar will take care of all of that for you. There's a very, very novel way of doing that. Unfortunately, we're not going to talk about that today. And then the message delivery, guaranteeing the message delivery, many different subscription types for consumers and things like that. We will get into that a little bit today, I believe.
Yep. All right. Okay.
Right. So the architecture of Pulsar, I'm going to go pretty quickly over this just to kind of save some time because I'm sure everybody wants to get into it. But basically, a Pulsar cluster has n number of brokers, a minimum of 1, probably at least 3 to be highly available. You have a Zookeeper, so that's your configuration store, your metadata store, a single Zookeeper instance. Your bookies, that's a bookkeeper instance. Those are your storage. Again, you're going to have many of those, probably to stay highly available and also just to replicate your data. Pulsar is going to take care of a lot of that for you. But these are kind of the players here when you're talking about a single Pulsar cluster. And again.
Yeah, I think it's kind of the same. I mean, let's move.
Yeah, let's move on. So this is going to be our shameless plug, I think, to Astra Streaming. It is, you can think of it as Pulsar as a service. Our Astra platform, you probably know, has Astra DB. That's the Cassandra offering. And so now we've introduced Astra Streaming, and that is our managed Apache Pulsar offering. We'll go past all this, the marketing stuff, but yeah, the deal is like the way that you get started with Cassandra, if you're familiar with that on AstraDB, like being given free writes and reads and all that each month, it's the same thing with streaming. No credit card, just get going, like learn Pulsar and don't worry about giving us any money until you're really going to go to production and all that.
Yeah, exactly. Yeah. So yeah, I agree. It's kind of marketing-ish, but hey, you know, we will use Pulsar as a service, nothing to install. Okay.
True.
Speaking of which, enough with the talks at the beginning. Now it's time for you as well to get your hands on Pulsar. Okay. So I shared the link of the GitHub repo with you all in the YouTube chat. So the link is also on the screen, but this is where I'm going right now. So here on my screen, I just went to the GitHub repo, okay? And I will give everybody the time to go to this repo. There you will find all the step-by-step instruction in the README, okay? So in 2 hours, we cannot really ask you to code the full app. So the full app is there. You will execute the commands one after the others, and you will show the data pipeline building labs after labs. So in this README, you find first the housekeeping, what are the objective material for the session. Remember, we told you everything is given for free, so including the slide deck. Okay, if you want to join the Discord room, answer question, twist back up. So then discussing a bit about the architecture design. So here what we will do is a full data pipeline. First, we'll create an injector that will produce some reviews. Reviews for hotel, reviews for restaurants. We could have generated them totally randomly, but it was done a bit more, it was a bit more clever. We make sure that the reviews will follow a predictable path, like a sinusoid, like here. And you can see over time what will be the review, either super positive or negative, of the hotel and restaurants. And in the middle of all those reviews, we introduce some troll, some stupid message. The purpose of this pipeline would be first to sort what are hotel reviews going in one bucket, one topic, or what are the restaurant reviews going to the second topic. This is what you can see here in yellow over here. Okay? When those review will be in topic, we will have a machine learning powered batch that will evaluate those reviews and find out which one are trolls, which one are relevant, and for the relevant one, we will save the data into the database. Okay, so that's quite a few steps. And so you will see first lab 1 in yellow, lab 2 will be the green one, and lab 3 with the red here. Okay. Again, if you want to know more about the injector, we provide you the details over here. What is the algorithm used? If you want to know more about the analyzer, same. All the details are providing to you. Okay. But we want to have the session as interactive as possible. So we would like to go to the hands-on right now. So the first things to do, and you will see I'm doing exactly the same as you. So the first things to do is to open GitHub. So here you have the button, but you want to open the GitHub in a new tab. So right click, open link in a new tab, and here we go. So I put GitHub on the right part of the screen, but I also keep my README on the left part because this is where I will copy all my command from. So as you can see, it's a real VS Code, okay, in the cloud. So full IDE. There you have everything you need to code with Java, Python. You also have C#, JavaScript. Docker is there as well. We set up the environment to provide you this pop-up in the beginning. What we want to do is to open ASTRA. So ASTRA is the platform where both Pulsar and Cassandra will run. Okay. So the first step to have Pulsar and Cassandra is to sign in to this platform. As David stated before, we don't ask you any credit card, and it's free for a pretty large workload. Until you go into production, you probably never have to ask the question, should you should you pay or not. So you can sign in with Google. This is what I will do right now. And you end up to the screen, which we call the dashboard. And in this dashboard, on the left part, you will find all the database that are running for you and all the Pulsar you called ASTRA streaming or streaming also on the left part. So as of now, you see I have a single database called MTG. I do have my full Magic the Gathering card collection there. I'm such a geek. So yeah, I don't want to stop that database. So I'm using, the product in a small production. And I'm still using the free, and I never consume all this credit as we told you. Okay, so hopefully you sign into the solution. What you will need is some credentials. We will interact with the solution through a CLI, a lot using some token. So you need that token. You need those credentials. And so to do so, what you will have to do is to go to setup 3, create ASTRA credentials. So I will do slowly, but it's also written in these instructions here. You can follow the link, but you can do that with me. To create a token, you will go to your current organization. You will go to organizations settings. See, now I move to a new screen that will give me some, everything related to my organization. Organization in the ASTRA world is your tenant. It's a multi-tenant solution. So organization is where you live, your home. Everything, every database you create, every streaming tenant will be in this organization. Okay, so what we need is a token. So we need to go to token management. Okay, token management. And there you would have to select a role. We will use, let's go, organization administrator. This guy can do it all. You are in your own organization. So let's pick someone with the as many credentials as possible. But as you can see, you can then invite users to your organization with limited permissions if you just want people to read your data in the database or use Pulsar as you like. Okay, organization administrator. And I'm going quite slow on purpose because this token is really, really what you need for everything else. And then you select generate token. Okay, so as you can see, a token contains 3 parts: client ID, client secret, and something called token. It's important to save the values that you can see on the screen because it will not be shown again. It's for security reason, FedRAMP compliancy. It's if you use AWS or Google Cloud, it's the same. Your credential will be shown only once to you. So please download your credentials. Uses download token details. It will generate you, as you can see here, a CSV file with all the values. Yet today, for the full workshop, we only need the token, the third one. So what I'm doing here, I will copy the token in my clipboard here, like that. As you can see, I see a notification stating me that it has been copied. I will probably paste that somewhere on my machine on an empty text file, and I will stay that on my second screen. You don't need to see it. Okay, you do not want to post the video and steal my tokens. Okay, I will disable them after the session. Okay, so I do have my token in my clipboard. Now I'm moving back to GitHub. Okay, so in GitHub, on the right part here, you see we do have 5 terminal opens. Okay, it will be the 5 parts of the labs for today. Let's go to number 1. And the first things that you are asked to provide is, guess what? Your token. So here, as you can see on the screenshot here, I selected producer. I put it my focus below that yellow line, and I will paste with Control V. As you can see, the first time you paste, your brother could tell you, hey, do you allow Gitpod to work like that? So please allow that. And it's enter. And now I'm telling you that your system, Gitpod, could now interact fully with the Astra platform, just with that token. And we will do some steps, and you will see that things will start to show up on the Astra UI. Okay, so it was setup 4-4. To show you that it's working, you can now go to setup-5 and ask to list the user in your organization. So in GitHub this time, when you have an instruction, you can go to the very left of the instruction and click there to also have that in your clipboard. Okay, so it's a copy-paste on steroid today. Okay, and so I will paste Astra user list. Okay, I can probably hide for now the sources. And as you can see, in the terminal, I can list my user. Okay. All right. Last part of the setup will be to create a database. And if you have been to our workshop before, you know, we always start with creating a database, going through the Astra user interface and creating the database. Now, with this command line interface CLI, we can do it right here, right now. So copy pasting this instruction, and the workshop database should start being created. So,
by the way, greatest name ever, Troll Squad. Greatest name ever.
Okay, that's not on me. Thank you, Stefano. Yeah.
Thanks, Stefano.
All right. Okay. Okay, so we are starting a Cassandra cluster, which is distributed database with multiple nodes. It might take 1 minute to to start up. Also, depending on where you are, Gitpod could also take more time to start up, to build the environment. So after the database is ready, I will pause, waiting for kind of feedback from you, like a thumb up in the YouTube chat, telling me that we are ready to go. Because this is based on this setup, CLI up and running, database up and running, that we can do some Pulsar magic. So it's starting, and I'm not lying to you. I can go back to the Astra UI and showing my dashboard, and you can see that workshop is there and workshop is pending. So I'm actually initializing a database. If you already have a workshop database because you are, happy fellows coming back every week, the database will be resumed if needed. After 24 hours, the database can go hibernated if you don't use it. It will be resumed, and the needed key space will be created for you with the fantastic name Troll Squad.
We're just working through a few details with everybody in the chat.
No, okay. Yeah, I see about the producer tab being empty. So here, lift off workshop is now active. And if I go back to my terminal, you see that the database has been created, and it took, almost 2 minutes here. Okay. Okay, so seems like Santiago is unblocked. Okay, great. All right. So now you can just go and say setup 7, Astra DB's status workshop. So here, Astra, that's our CLI. DB, we are targeting the DB services in Astra platform. Status, get the status of my database called workshops. And here we go, it's active, no surprise. And you can also issue the command Astra DB get workshops to have the details of this workshop. So what is important to notice that my database is using the region called US-East-1. This region is hard-coded in some configuration file. So if for some reason you add the workshop database before working on another region, I do have one extra step for you to do, but I will explain when it will be time to do so. Okay, and this is the end of the setup. So, folks, I will wait for you now and answer any question.
I think everybody's getting untangled here.
Yeah, it's not a tricky part, but it's the more the part that needs the more focused. Because after all, you started Gitpod, you had to sign into Gitpod using your GitHub account. Then you had to sign into Astra, create your token. Oh, by the way, if you want me to show how to create a token again, because sometimes we got the question, you go here to organization settings, token management, and this is where you can create your token. Yeah, so go ahead, David. I interrupt you, I think.
No, well, I was going to say, we saw that everybody attending the workshop is throughout the world, and everybody's latencies are going to be different here, for GitPod and for Astra interactions and all that stuff. So it's quite interesting to just see it all go down.
Yeah, but also, as Nightbug just said in the chat, the workshop is recorded. So after the session, you can watch the stream at the very same link. So if for some reason we are moving too fast or you get an error during the initialization, keep follow what we are doing, and you can come back and do it at your own pace. The homeworks for the session would just be to complete all the steps of today's labs. Okay, so you should be able to do it on your own. And by filling the homework form, you get a badge, and with this badge you can brag on LinkedIn because it's an OpenAPI badge, official badge. We now have, I think, about 20 badges, one for every topic we do. We tend to do some topics on Cassandra, of course, a lot, building application on Python, JavaScript, Java, using all the trendy frameworks, building some API microservices. And now, boom, part in the mix, Pulsar and real-time data pipelines. So it will be, better and better.
So when you do earn the badge, I highly recommend putting the badge with a magnet on your fridge. Take a picture of all your badges on the fridge and tag us on Twitter, DataStax Devs on Twitter. We need to see that, all your badges.
Okay. Oh yeah. I want to think that so much. Yeah. And you know what? We should have a page on DataStax somewhere with like a leaderboard. Who has the most badges? That'd be wild, right? And let's say, get a T-shirt if you got that many badges. That's coming. Okay, community in the DataStax, community in Cassandra and Pulsar world is getting bigger and bigger. So Okay, so I see a first Arnab stating that is ready to proceed. I could wait a couple more minutes, as I stated before. Important is for you to keep follow and not rushing into the content, even if we not finished everything. You know, that's not the most important here. Let's have fun. Come on.
If everybody could, if you are up to speed, can you just give us a thumbs up in the chat so we know everybody's kind of keeping up and everything's working? Wow, crickets. Okay.
Yeah. But you know, it's not bad though, right? Cricket seems like people are very focused. And if you need, yeah, to that I will show up again another step, we could proceed. But if not, you know, now we are ready to fly. Oh, during the time that you reproduce the steps, I can show you that now your Astra CLI is fully set up. So if you show Astra config list, which is some kind of extra command, you see that as of now, you have one organization setup and that your organization is the default one. So meaning you, for the command you issue, you never have to provide the token again. It's saved somewhere and will be provided once needed. This is why we had to create that token first and save it in with Astra setup. Okay, what time is it? Looking at the clock a bit here, over here.
Wow. Quarter to.
One more minute and we move on.
And so the next step there is we're going to get into the tenant, huh?
You
Now
are,
that we got the base.
yeah, you are correct. And you know, a tenant name should be unique for everybody in the same cluster. And using the CLI, we will use the same region and the same cloud provider. So we need to find a way for everyone to have a unique tenant name. And to do so, I use some randomizer. So
Oh, look at that.
everyone will get a tenant, and I think it's 9 digits after that, or hexadecimal. And so if now I issue the command lab1-1 here, I got my very own tenant called troll squad-m8cznrmm. So it should be unique, but you know, if by any coincidence you got the same or anyone got twice the same, just rerun the command export tenant to get a new name. But come on 8, that's one chance in what, 110 billions? No way. Okay. Now even more, because we also use the letter. Oh no, come on, no chance. Yeah, no way, no way, no way. Okay. So now I do have an environment variable called tenant, because again, I don't want you to copy paste. And so this tenant could be reused again and again and again. Okay, so lab 1-02, let's create that tenant. Okay, so here, Astra streaming for the streaming part, create and tenant. So here we want to create a tenant, all right? So troll has been created. If I go back to the Astra user interface, the dashboard, the home. So to get to the home, always click on the logo. You're always back to the home. And you can see I do have my database called workshop and my tenant called troll squad, M8, blah, blah, blah. Okay. And of course, it's empty. You have, you know, no topic, nothing. The default namespace is default. Okay, so we have one namespace and it's called default. You can have multiple namespace to organize logically your entities inside Pulsar. As of today, everything we will create will be in the namespace default. And yeah, to me, it's the same principle as what you can find in Kubernetes, where you have a namespace and you create your object in the namespace. Okay, so keep moving. Now I could list my streaming tenant with Astra streaming list. So you should not be surprised because we just did Astra DB list a moment before. So we are using the cloud AWS and the region UST2. We could have used another cloud, another region. Astra provided diversity of clouds and regions. So the big three cloud providers are there, of course. But for simplicity reason, again, some regions are hard-coded in the exercises. So let's just use those two. Okay. All right. So now it's a cool, I mean, I find it cool, maybe not, you not, but to interact with Pulsar, we already have a CLI, and it's called Pulsar Shell, Pulsar CLI, with two parts, admin, called Pulsar admin, so to interact with your tenant, create entities, and Pulsar client to actually send and receive message and do more. And so what the Astra CLI is doing here is just downloading the Pulsar shell and wiring with the proper parameters. You don't have to download something called client.conf because it's generated for you on the fly by the CLI. And right here, right now, I am now connected to my tenant using Pulsar shell. No thread. So no client.conf. Okay, so now I can go and enter some admin commands. So admin namespace list. I told you you should expect a single namespace, which is default with your tenant name as a prefix. Okay. You can also now list your tenant. And here you go. Empty, no surprise, it's a fresh tenant. Let's now create some topics. So here we will create 4 topics. So the first one is called $r-row-in. This is where all the row reviews will come in from the injector. Okay, and I will move. So hotel review. The name is pretty explicit. Restaurant review, same, copy paste. Restaurant anomalies, if we detect some troll in the reviews, they will be routed to this dedicated restaurant anomaly. And to be honest, it is the most interesting, right? This is the one that we want to analyze and see all those trolls. All right, so after executing the command, you can go back and list your topic. And this time, hopefully, you get your 4 topics running. Explanations are provided below, okay? And yep, you can exit. You can now exit Pulsar shell to keep going with the command, okay? We are done with creating the topics. So now let's go back to more setup for what's coming. Okay. You are probably right now doing the step-by-step issuing the command. I can show you again the user interface. Here is streaming. So now I can go to topics. Okay, probably I just have to refresh this guy. It should be there. So here I have my 4 topics and I can expand. And here you see my 4 topics. Okay, should not be a surprise. But as you can see, I hope you find it neat to move quickly to the entity creation with the commands. Okay, all right. So now we are ready to start a Python job that will generate those review events and send them to the Pulsar topic. So this is what we call a producer. But this Python component will need to know what is your tenant, what is your token, what is a couple of things, and we will define those as environment variables. and this is what you see in lab 1-9. We are creating a file called -env that will actually create this file for you. So just copy paste that. So getting your ASTRA database, your ASTRA token, tenant name, Pulsar token. For some producer and consumer, you need to provide the Pulsar token and what we call the broker URL. And it's all created with this little script. So the last command is tail -5, just for you to see what we just created. We just issue those Pulsar token as an environment variable, org ID, your organization ID as a tenant, as a environment variable, and so forth and so on. The last three commands, like set-a, source, and set+a, is actually reading the file and loading everything as environment variables. So now if I do echo and pick one of those, let's say org ID, I should have it, okay? And so all the commands that we will issue will have those variables. But at some point, the terminal will be busy, if we produce some messaging, and we will have to change terminal, to keep doing commands. When we change terminal, we need to reissue the command source.env for the new terminal to be aware of the context, okay? This is how we share the context in between the terminals. Because, you will generate a bunch of message very soon. I think we put the frequency at 10 messages per second. So yeah, ASTRA folks, people in charge of the cloud system, we are coming right now. All right. So lab 1-10 is actually using this command to open the ASTRA UI. It will end up with this screen. Okay, so I can move quickly. And same for, maybe for the topic, let me copy this one. So, I did not lie to you. It will open ASTRA exactly where it needs to be open. So using org ID as environment variable, I was able to know which org, and also with the region name, tenant name, topic name, everything is there. So I can route you directly to this topic information. So as of now, no producer, no consumer, it's empty, no subscription, so nothing happening right now. So let's do some stuff. Okay, right. Start Pulsar shell again. Should we? Oh no. Yeah, I was thinking no. Let's start the generator first. So lab 1-12, start the generator. So if I show you the sources, it's there, rev generator, and it's called review generator.py. So connecting to Pulsar using a Python client. Actually, it's in Pulsar tools here to get this Pulsar client reused on multiple Python components. But this is what it does. And then it will initialize this producer. And there we have a loop using the sinusoid, as I explained before, just to keep sending those message review. Okay, so let's try to start. Okay, so I copy my start command and paste my start command. Okay. And here we go. So congratulations, you just have your first producer that's sending 10 messages per second to Pulsar topic called RR row in. So now if I show you this UI, depending on the refresh rate, it will start showing up stuff. I can do a I'll refresh. Maybe we could ask the team to have a refresh button somewhere eventually, you know.
Yeah. And to be clear, so what the producer that Cedric just started is mimicking restaurant reviews, right? So think Yelp, and you know, everyone is putting reviews in for this restaurant. Some of them are trolls and some of them are real, and so that's what that script was mimicking.
Exactly.
Those reviews.
Yeah, you got it.
Hey, look, there's numbers.
Mm-hmm. So yeah, it's going, and we will keep it like that. So because it's keep moving, we cannot use the terminal here. We need to change terminal to keep issuing some command. And this is where we are moving to terminal number 2, which is consumer. Okay. And as I told you before, the first start you have to do is really to reissue that source.env. You know, we want to have those environment variable to get ready. If I would like to test that my tenant is now there, see, it's there. It's a different bash, but still I was able to get by my context by using this source command. Okay, we have somebody that's sending some message. So what if we just read those message? So to read those message, we could have implement a consumer in Python, exactly as we did before. But for now, we can also just leverage on Pulsar shell and actually Pulsar client inside Pulsar shell. So here, step 1-13, I will start again Pulsar shell. And you know, you will see I keep opening Pulsar shell and closing Pulsar shell. It's a better flow than, you know, trying to have Pulsar shell open somewhere and go back at it every time. I think it's easier to stay here and understand what we are doing step by step. So I'm back into Pulsar, and this time, instead of issuing some commands starting with admin to, for instance, create my topic, I will do some client, consume, and provide the name of the topic. So -s will be the name of the subscription, you know, just to know, hey, this is who I am, just to identify the consumer. And -no, N actually mean how many messages do you want to consume, and -o is, you know, keep reading those messages. And if I do so, now we are also reading the message. So producer, consumer. So we are using kind of the basics of Pulsar. And that's it for lab 1. So I will kill the consumer for now, keeping the message piling with the producer. And maybe wait for you just to get a little bit of feedback in the chat. Just say, oh, you are moving way too fast, or you are able to keep up with the pace. I'm just copy pasting the command and getting that working. Anyway, we will have a couple of slides to share with you before moving on. So what we just did, we do have this injector in Python, creating a producer sending message to the topic. So WRO in, and we are used Pulsar client to consume those messages and show them in the terminal. But this consumer piece is pretty weak sauce. So let's try to spice a little bit the game. And you know, to spice the game, maybe I can go, you know, quickly with that. You want to have a treatment that will work in real time, that will do all the machine learning magic that you expect. So, and in machine learning, you have multiple big algorithms like classification. So you can expect that if you classify your event, you can route them on multiple topics. So regression, clusterification, regression could all be done in real time. Like you can compute an average over the time, and some algorithm can work very well over time, and you can fine-tune your model by events coming and again and again, as something we call reinforcement learning. In the event streaming world, the machine learning algorithm is mostly to do fraud, detecting some events on a certain period of time that should not happen. You can do some social media customer, or obviously some IoT data ingestion and classification. And this is kind of the latest that we wanted to simulate with these program that will route your events either on hotel review and or restaurant review. Okay. So here, I can also move here quickly. What you want to do is fine-tune your model based on the event that's coming in real time, and not only with your initial load. You tend to build your model with initial load that you could have put in ASTRA DB or Cassandra. To be honest, that's a tabular-oriented database. Totally what you expect to train your model. Neural network. You get your model, but you want to keep improving your model over time. And so having some treatments in the data flow could help you. So first executing your model, but also improving your model over time. And the very basic could be building a threshold. Let's say I would like I'm spotting an attribute which is an integer in my message, and I would like everything to go above the average to go in one bucket, and the other to go to the other bucket. Well, this average will be recompute all the time, and so your threshold will adapt with the kind of flow of events that come in. So imagine that instead of a threshold, it can be like a real recursive network, RNN, so recursive neural network, where you keep training your model with new message coming. So I think you got the idea. All right. So now we want as well to train in real time. Okay. So for today, now what we want to do is, okay, we got the review. Is it a real person? Does it violate? Is it malicious or not? What is the type of review? Hotel, restaurant. Actually, hotel, restaurant will come first. And so we will route that and detect anomalies in real time. That's the business overview of what we want to do. How do you do that in Pulsar? Well, you are using something called Pulsar function. And now that's back on you, David. Explain us.
So to give you some context here of Pulsar functions, this goes in the direction of stream processing. And the idea with stream processing is you work with the data in memory as it's received, right? It's the fastest possible way that you could work with the data. Obviously, these have to be fairly small, bite-sized kind of functions and actions. But the idea is these functions, and you can chain all the functions together, but the idea is you could filter information, transform the information, enrich it, take a single data point, look up some other data about like maybe a user profile or something, enrich it with other information, windowing, cleansing the data, processing data, all these different things for Pulsar functions. To understand maybe some other ways to do this. You could involve Flink in this as your stream processing system, as opposed to Pulsar functions. I'm a big advocate of Pulsar functions. You can do them in Java, you can do them in Python, and they're quite useful. But quite frankly, you know, there is a separation of duty here, and your data scientists and all that may not know Java or Python, and they probably know Python. But just accomplishing some amount of separation of duties and roles and all that, I see a very common thing of the stream processing is one system, and then the Pulsar cluster is another. So it's topics in, topics out as far as function goes. It can watch multiple topics, but a function is always going to output to a single topic. And then what that function does in between there is up to you, because it's all pure Java, pure Python. You're given the context of what the message is and where it came from, and you can do whatever you want inside of there. You're in a proper environment, programming environment.
Yeah. If I may, you know, you spoke about Flink. You know, it's a new shiny. I'm the old guy, so I used to use Spark streaming. You know, same principle.
Yeah.
You know,
Yeah. Same.
And you know, where is the limit? What should you put on a Pulsar function? What should you put on Pulsar streaming or Flink? Well, there is no big technical blocker. You know, now as David stated, you want to do this segregation of duty. As long as you want to use the data that are mostly in Pulsar, let's do a Pulsar function. Also, try not to have a huge deliverables inside a Pulsar function. It's meant to be a function, not a Pulsar monolithic inside a function. So keep it lightweight if you can. And if you need some complex algorithm, like you know, fourth type languages, real algorithms with loops, with aggregating multiple data source, not only in Pulsar, then this is, to my understanding, my own ideas, when you come and, you know, go for Spark streaming or Flink.
Yeah, because you're gonna, I mean, you know, all of that is compute, right? Having to process all that. And again, you're in memory, you're trying to do this in as much real time as possible. So the more calculating you do, the slower that processing is going to be. So Cedric's right, like you got to find a balance.
Okay, let me put back the focus. And hey, here we go, dedicated Pulsar function screen.
So as I said, a function can watch multiple topics. It's going to output to one. A function can also be given a log topic. And so that's kind of nice for debugging kinds of things. So in the Java, you're just going to naturally write to log, right? You're going to do a log dot whatever. But Pulsar is going to translate that into this Pulsar or this log topic. It's quite convenient and a very, you know, native way of doing it for your runtime. But again, it's you can think of it as a function. You can assimilate it to AWS Lambda or Google Functions. It's the same idea, but you're in the middle of a messaging system here, so you're moving quite fast.
Oh yeah, totally. Yeah. Okay. Yeah. More to come for the log topic, I guess, at the end of the session. I was thinking about moving those logs somewhere else eventually, but you know, we will come back to that later.
Okay. Yeah.
Okay, so here we do have our topic that keep filling right now. So let's create a function that will route the message where it needs to be.
And as Cedric said, we're going to be in Python for this. So we're going to create a Pulsar function, and the Pulsar function is going to be looking at the raw reviews coming in and asking the questions: is it a real person? Does it violate? Is it malicious? And then once it gets past that, then it's going to parse it out and figure out what kind of review it is, for a restaurant or a hotel. And then based on that, it's going to filter, and the restaurant reviews are going to go to one topic, and the hotel reviews are going to go to another topic.
Correct. Okay, so let's try to do that. Pulsar.
Lab 2.
Pulsar function. Okay, moving back to my nice GitHub. Hopefully, it did not time out. Okay, sometimes it can time out. If it's happened, hard refresh. You should have your environment file ready to go, so you can go back and do the lab. Okay, so lab 2, Pulsar function. I will move to the analyzer. Okay, so analyzer number 3. Also, that means I could have kept the consumer running. But, you know, I stop it. That's fine to me. Okay, so here we will first, as stated before, we will first get our context with this source.env, because we really want to get that tenant and all the variables ready to go. So done, it's there. So now let's open the Pulsar function file, and here it is. Oh, you can execute the block as one go, but what I like to show you is that. So here, so it's a Pulsar function. So what you want to do this time is to read what's coming. But you know, the read has been, you know, it's the read function is kind of provided by Pulsar itself. So we just have a function with the message coming in, and we can just process them. We don't have to connect and find. It will be part of the setup to list what are the topic in. And so
if I could, Cedric, the reason that this is a Pulsar function, right, because it's just Python, is Pulsar, for the different runtimes, Pulsar offers an interface and defines what a function must implement. In Java, it's a proper interface, right? For the class that you're going to be implementing here, we're in Python, so it's a little bit looser, but notice from Python import function. And so now our class needs to have some certain definitions and define certain things in there. And it needs to actually take in certain values and return certain values and all that. And so that interface for a Pulsar function that we brought in, that kind of forces us, or qualifies this, I guess, makes it a function.
Yes. So this function will run inside the Pulsar runtime. So I cannot just use my environment variable, my context. I mean, the source code could be self-contained with all the variable needed to run. So, and this is the tricks I use today. So I put the topic list over here as a dictionary at the top, and I put a key called __ tenant __. So we cannot deploy the code as is. We need to change that value with your own tenant name. Well, guess what? This is exactly what this sed command is doing right there. Okay, so it will, yeah, let me copy it properly.
Not only are you going to learn about Python, not only are you going to learn about Pulsar, but you're also going to become a Bash wizard here.
Yeah, a CLI and a Bash wizard. Yeah, sure, of course. Yeah, so you know, this little trick is not bad, because now our file actually contains our tenant name, and it's now ready to go to be published. So how do we publish a Pulsar function? Guess what? We will reuse the admin CLI, so the Pulsar admin. So guess what? First, we will need to start Pulsar shell again. So let me copy paste that. Here we go. Start again Pulsar shell. So I can close this file. We don't need it anymore. It's now updated as expected, and I'm back in Pulsar shell. So now lab 2-3, I will first list the function. Okay, so function has entities like topics, namespace in the Pulsar realm. So here I'm targeting the namespace default. No surprise, as you can see, it's empty. There is no function. So let's create one. We're using the admin function create. So admin function delete, it's just there as a helper if for some reason you provide the wrong environments and you want to get stuck. I could have hide these, and if you execute it right now, it's not harmful. It will just tell you that the function does not exist. And look at how canny I was there. I put the delete function before the create, just to be sure that you do not execute the delete if you do not want to. Okay, so here I'm admin function create. So a couple of parameters here. The Python file, sure. The class name, so as we saw in the file, tenant namespace, okay, where do you want to deploy that? Router function name and inputs. So you need to provide the inputs to Pulsar, and this is the Pulsar job to read the message and send them to your function. So now I probably could list my function again, and I will list. Okay, I copy. I should have done that in 2 steps. So first list the function, okay, and only that, because I do, and only then exit. Because now it's
you want to take a minute and do you think it would be valuable to talk about like where the function's actually running, just so everybody has an understanding of the function scalability here of Pulsar? I think is pretty powerful, mainly because it's just so simple to do.
Please do.
So as Cedric logs in here, you're gonna see that he's gonna go to the functions tab, and I'm sure you're gonna see the function running. But where in the ether of the world is the function actually running? So you have your own. You have a Pulsar cluster, right? Your tenant is the troll squad dash blah blah blah, and as a tenant in the cluster, you're going to ask to spin up a function, right? And you provided the Python file of that function. There's 2 options that you can use when you first run Pulsar and configure Pulsar. You can run functions with the broker on that broker instance as a separate process, or you can use what's called function workers. And so those are completely separate instances running just functions. Or a third one, if you're running in Kubernetes, is you can run each function as a pod, as an individual process. And in fact, ASTRA is running on Kubernetes, and so that's what's happening in the background. When he sent that function up, a new pod was spun up, and within the pod was obviously this function running. It's a very, very limited lockdown pod, very, very limited on what it can do. And it's just running this function and using the scheduler in Kubernetes to make it available and run a certain number of replicas and all that. So that's just understanding where the function is actually running. It's not running on Cedric's machine. It's not running in Gitpod or anything. It's running in Astra Streaming now and making it highly available and making it always available. It's managing all that for you in Astra Streaming.
Pretty cool to have these compute, and I assume what the function might scale based on the throughput in your topic. Is there a way to?
Actually, if you just scroll down a little bit, you'll see an instances there.
Okay.
And you can scale up. You can manually scale it up right there. Okay. You could get into some wizardry for scaling the function out, but it gets involved.
All right. Okay. I don't mean to automatically scale out, but I mean if you need to scale out, you can go there through the UI, boom, and probably through the Pulsar admin command as well. So pretty cool. Okay, so now if we want to look at the 2 topics, the 2 destinations topic, hotel review and restaurant review, you can again issue those commands. I will be lazy and go to the topics, find out my hotel reviews first. Oh, it seems like I do have a couple of messages there. And back to topic, and I will pick the second one, which is the restaurant review. And here I go, way more message. So it seems like more restaurant than hotel reviews. And that makes sense, right? We go more often to the restaurant than the hotel. Okay. All right. So in this lab 2 already, we were able to deploy that function and write into 2 topic. So here, lab 7, kind of cherry on the cake. I can go back to the Pulsar shell and consume that restaurant reviews. So not very different from what we did before. But here, what I would like you to show is what are the message look like. So here I did -n5 probably, or -n something. I did not keep consuming the message. I just wanted to extract a bunch. So here we do have a JSON message. And because it's JSON and formatted, we can now do some, algorithm analyzing NLP based on the text, based on the category, and based on not the score here. The score was too for the routing, but here you see that we are so Pizza Smile reviewing some pizza and putting some degusting the dishing risotto. So I think it's good to see what kind of message are moving across those topics, because eventually we will save those message somewhere else. So it's nice to have as well the structure of those messages. So now I'm exiting Pulsar shell. Okay, and I can go and start the analyzer. Okay, so I can stay here for the analyzer. It's called analyzer. So let's go copy that and paste the analyzer. So this time the analyzer, ref analyzer. So the analyzer is a standalone Python batch. Okay, we could have also do a Pulsar function, but this time we evaluate that as it's involved maybe heavier libraries, maybe having a standalone batch and coding our own consumer would be nice for the workshop, because you have seen a producer. What about the consumer? Here you have it. Okay, you will reuse that Pulsar client, okay, get Pulsar client function that we used in the beginning. And instead of produce, you will consume. And here you have a nice forever consume loop with a couple of arguments that you can set up to tune the analyzer. I've not myself go into too many details of the analyzer. But here noticed is using the environment variables, because now it can. It will run on GitHub here and now being deployed. And not only it will analyze, push the result in dedicated topic, so the fourth topic called review anomaly, but it will also save some reviews into the database. AstraDB, the one we created before. Okay, and when it does initdb and when it's saving data into AstraDB, there are multiple ways to save to AstraDB. And here is using a REST API. Okay, but I do have a few slides to cover the database we are using. So I will simply start the analyzer, finger crossed.
As he starts it up, the analyzer is going to keep the average rating per hotel, but it's just going to keep it in memory here, right? So he's just running it right off his Git pod as opposed to a Pulsar function. And so it's looking for messages that it considers trolling, so not legitimate reviews. And then for the things that are legitimate, in memory per hotel, it's keeping the overall average score. So like of 5 stars, right? If you're on Amazon, an individual thing has 4.5 stars, 265 reviews. That's what it's holding in memory here. That going average per hotel.
Yeah, pretty cool. I could probably just adapt my terminal just to show exactly the same output each time. And you don't even notice that it's keep refreshing. Okay. I could have, I could go to the reader and read these last topic quickly. So copy pasting, getting my context, starting a reader. So the reader this time is not a Pulsar client consume. It could have been, but again, here we wanted to show you more code. So now again, you have a consumer written in Python that will simply show what are the outputs of the anomalies, or the troll, if you wish. Okay.
And it quickly, the difference between a consumer and a reader, because those are very similar things. The reader is a concept in Pulsar, where think about I like to think of it as a playlist. A consumer is actually consuming messages, so there's acknowledgments going on there. And once a message is acknowledged, then it's dealt with. It's either persisted somewhere or it goes away or whatever. The consumer can control the life cycle of a message. A reader, think of it as it's going to come into a topic, and you're going to give the reader a cursor and say, start at this number message, start at 0, start at 50, start at 100, and read messages from there. Start reading messages from there, or start at 50 and go to 100 and just read those messages. So it's a bit of a replay. I think of it like kind of like a playlist. It's like I have a playlist of songs, and I can either start that playlist as the first song, or I could start at the 5th song and then just start playing from there. That's kind of the way I think of a Pulsar cursor.
Nice. I was not aware. Okay, thank you. All right, great. Okay, so yeah, no, I know. If I want to replay just a partition, a part of it, I would go through a reader. Yeah, nice, nice.
Because remember, our topics were persistent topics.
Yes,
right. So the message data after it's acknowledged is going to stick around in your bookie, right? But it's just Pulsar's not going to necessarily make it available to consumers because it's been acknowledged. But readers can come in and get those messages.
Okay, right. So these analyzer also write some data directly into the database using some Python code. So maybe a couple of words on the database we are using. So if you join the workshop every week, you know that we are using a lot these Apache Cassandra NoSQL databases, which is a masterless architecture. The data is distributed, is replicated on multiple nodes, group as ring or data center, and you can distribute data center across the world. So like that, you have the database, the data as close as possible to your client and reduce the latencies. So it's an Apache project, and it's well known for its scalability. Okay, so the data is partitioned. I can move. So the scalability is linear. If you need more throughput or more capacity, simply add new nodes. So the more, the more throughput you might have, the more Cassandra would make sense to save those. So here, some Netflix benchmark. So at Netflix, they do have about 100,000 Cassandra nodes, so multiple petabyte of data, and I think it's about 30 million instructions per second. It's massive. So very big player, Apple, Netflix, but maybe many others, Alibaba, Huawei, using Cassandra for that reason. So I told a little bit about the replication. You can replicate on multiple ring data centers, and Cassandra will replicate the data for you under the hood. So you can interact with the data which is close to you. Cassandra will replicate asynchronously to others' location. Also, you can say, hey, in Frankfurt, we do have a GDPR, and I do not want my data to move out of Germany. You can set up that, and these data will stay there for legal region. In the same database, you can have multiple In the database, we can have multiple key space having those replications. Okay, so yeah, I told about that. So you can think about these distributed database as a way also to have a single data layer across multiple technical stack eventually. You can deploy some ring and cluster across the cloud and do some inter-cloud single data layer. Okay, so it's a technical workshop, so no magic here. You still have to pay the data cost of moving data across cloud, inter-cloud, but technically speaking, that's totally doable. Also, Cassandra is an open source database, Apache license. That will not change license anytime soon. It seems like a lot of people decide to change license lately. I mean, that is, Cassandra does not have to get protected against the cloud providers. It's easy to deploy on a tarball anywhere. And yeah, so that's the Apache license. So here, what we want to do in lab 3, so lab 3, we just get, hey, look at what the data has been written by the analyzer. But lab 4 will really be, okay, everything that I will write in this topic should also be replicated on my database. Before David talked about this log topic, maybe this log topic could make sense to also be saved in the database, just to have this flexibility in the way to querying the data. Eventually, if you feel about limited by the query system or the query pattern on the broker itself, which is, you can do a lot. There is Pulsar SQL there. You can do a lot, but having that.
Yeah. But that's a good point, Cedric, because it's kind of a blurry area, because if you look at Apache Pulsar, it does have Pulsar SQL, and it claims, and you can write SQL queries against a topic.
Mm-hmm.
So you'd say, and Pulsar is going to persist the information, but the honest truth is you get into a just usability point of view. Technically, you can do it, yes, but that doesn't mean you should. And so this is a good point of like writing the logs to a topic, not necessarily going in and watching that information in that log topic, just using it as a vehicle to get to a table in AstraDB and then querying that. And it's a lot more natural way of doing things. You're using the drivers in the right way. It's just a better way of approaching that.
Okay, all right. No, just was banning some, stupid guy sending stuff in the YouTube chat. Okay, so keep moving. All right. So that's the database. So, before Pulsar IO, let's do lab 3, okay? And you can do that pretty quickly. So I still have my everything running. So to go to the database, I will move to terminal number 5, just to get a fresh start. I will again initialize my context with this source command. Here we go. And I should still have my tenant. I keep doing that just to be sure it's okay. So it's okay. I do have my context. So now, when you're interacting with Cassandra, there is a tool called SQL-SH. So SQL means Cassandra Query Language, and SH for shell, to interact with the database. So first things to do is to go to the ASTRA user interface, pick the database you want to look at, go to SQL console, and then interact with SQL-SH. So here we are doing this command. We want to describe a table. So we can do that, and it's working. Okay, and you can do that here. But because we will issue a couple of commands, I was thinking maybe we can stay in GitHub, and instead of doing that through the UI, we can do exactly the same as command line. So here I will do Astra DB SQL-SH, so to use Cassandra Query Language workshop. It is the database name I would like to target, and -e I will execute. So here, without moving anywhere, you will simply execute the same thing. So most of, everything that we have done today through the command lines can also be done in the user interface, of course. But it's also cool to see the CLI. It could help you, CI/CD pipeline, and to be honest, to do a 2 hours workshop and showing all that, it speed up things. Okay, so I do have my table here. Okay, it's not exactly the output. I've hidden some metadata. We have dedicated workshop exactly on that. So keep moving. I will simply keep showing the table that had been created. So here I am using the CQL, so Cassandra Query Language, which is a default way to interact with Cassandra. And as you can see, I can issue some describe command, some select command, and I can, of course, insert data if I would like to. So here I'm just selecting stuff, and look at that. For some magic reason, I even import the colors. So I'm not even totally sure why I still have the color there, but it's working. So pretty cool. So now if you want to get the status of a restaurant, so a couple of commands we can issue like that. But the analyzer is not using this SQL way to interact with the database. I mean, it could, okay? There is a Cassandra drivers in Python. It could have done that. But it's a little, again, cherry on the cake that you can have there in the code. That when you interact with the database, there are also APIs. I mean, in the beginning, we saw, today we also have people from front end. So what if you could interact with the database right away with a REST API? Guess what? Well, you can. You even have here the Swagger UI. And if you want to play with the database, here you go. You have it. You have the GraphQL API. Same. You can go there, open GraphQL Playground, and you are good to go to interact with the database using GraphQL. So, do not want to take too much time on that today, but that's available to you, and it is actually how the Python analyzer works. Okay.
If you want to explain for a minute, just to give somebody context, we go back to the terminal there, and so remember the analyzer was running on inside Gitpod, right, and it was holding the average, and so notice that select actually the second one up select. It has an average 3.16151. That is the analyzer holding the average and writing it to AstraDB every once in a while, right? For that restaurant, Veggie 00, there's their average stars. There's how many hits they've had, how many reviews they've gotten, and the name of the restaurant, and how many outliers they have. So anomalies and things like that. And so this is like the real part of this, right? Everything else we've set up was infrastructure to get going, to be able to do this, to be able to process it. But this is the result of processing that information and actually having something, that resembles a product.
Yeah, and you can also see that the data is formatted in a way, to push the reads. Having that on the database is also a way to change the format and apply a transformation to make it easier for some reads and queries. Okay, last piece for today is something called Pulsar IO. So I mean, we can go quickly on the single slide and do the hands-on. So David, if you want to say a word on IO.
Sure. Yeah, we'll make this quick. So the other, along with functions in your messaging system, the other powerful things are sources and sinks, also known as connectors. These are kind of the three things. Yes, you have topics, and when you're going to just do simple pub sub, you're going to move messages around on topics, and you're not really using the messaging system necessarily at its full capacity or its full availability. When you get into functions and sources and sinks, you're getting there. Sources are, I want to set up a data source, right? And every time a record is written into this data source, I'm going to watch that, and I want that data written to a topic in Pulsar. And then a sync is I'm going to watch a topic in Pulsar, and every time a message is written there, I'm going to write that message to some data store, some sync. Pretty straightforward. Think about like sources. Think about you can get into Debezium when you're talking about change data capture. You can look at another messaging system. There's a Kafka source. There's Postgres sources. There's Cassandra sources. There's Microsoft SQL sources. All kinds of different things. And then syncs, kind of the same deal. There's Elasticsearch. There's SQL. There's all kinds of different syncs. It's just a matter of how you want to arrange your real-time information coming in from like microservices, and then your batch information maybe coming in from sources, and then all of that syncing to some other store.
Yeah, so yeah, pretty extensive, So real Swift Army knife to get data going in and out. So today we have all the Pulsar flow, so we just decided to go with the sync, and the sync go to the database. Okay, so pretty straightforward. After the analyzer worked into persistent data, here what we wanted is, instead of going with the REST API, having one of the topic as a sync, so created a sync on that topic just to be able to, for Pulsar to actually write into the persistent data without having to code it. Okay, so it's just reusing that topic code anomaly and make everything needed to have those data also persisted in DB. Okay, so we'll be pretty quick. I mean, it's not hard to do actually. Once everything has been set up, it can go pretty fast. So the first command there are really just to go back to Pulsar client and consume that topic at the end, just to see what does the events look like. Okay, if you want to save those events into a database, what you need to know is what is the structure, what does it look like. Okay, and based on that, do some assumptions. So here you see a couple of messaging read. So if I format this message a little bit, it's a JSON, and here are all the metrics. So you will create a database and a table. So inside the database, you will create a table with exactly the same fields, having the same types. Okay, so here I call that table RR MSG underscore RR topic restaurant, which is the name of the topic. Mimic the same field name and type. And in Cassandra, you want to build your table based on your request, because you will be able to execute some queries against the table only based on colon part of the primary key. So I had to do some assumption. I say, hey, based on those fields, I think the IDX will ensure the unicity of my record. Okay, but what I would like to do is really to search by user. And so here we mentioned that in Cassandra you need to partition your data. It will be partitioned by user ID. User ID is what we call a partition key. And IDX is the second part of my primary key. It's called a clustering colon. And here the purpose is to ensure the unicity. Okay, it's like relational databases. The full primary key should ensure the unicity of the record. Okay. All right, so let me exit that Pulsar shell, maybe clear the terminal just to go here. So let's create the table. To create a table, or you can go to SQL console, but you can stay here and use db SQL sh workshop-e as we did before. Instead of searching for data, now we're just creating the table. It's there. I will just execute the describe just to validate that the table exists. And I can show the content, but the content will be empty, right? Hopefully it is. There is nothing supposed to be written there. Okay, it's empty. All right, so now let's set up Pulsar to connect that topic to that table. I mean, everything has been put in place. We could have done that in the CLI as well, with a little bit of setup. But for the last piece, let's relax and use the user interface. Okay, so I'm going to Astra user interface, sign in again. Okay, okay, I was already there. So let's go back to the user interface. Locate my tenant, locate my sinks. Okay, so Pulsar.io sinks. Nothing. Let's create a new one. Okay. All right. So what are we targeting? There is a single namespace, is default, the sink type. So remember, David showed you that you can write into a lot of target destination system. Because this is all supported out of the box. Of course, here, I don't want you to install anything. So we will stay with AstraDB. Okay, and let's put a name. I put that sink anomalies because it will link a table called anomalies with the topic anomalies. So what is the topic? I said I would like the anomalies one. So pretty neat that it's listed there. I don't have to enter it manually, it's there. What about the database now? Look at that. It's also helping me. And this is also the reason I say, let's use the user interface. Okay, I do have a single key space. What the table name? Oh, look at that. Even the table name is there. But that's not, no, this time it's not, no, this time.
That was a browser.
Yeah, this time is my brother that remember. Maybe I tried the hands-on before going live. And
cheated. That was cheating.
Yeah, that was cheating. Yeah, yeah. And yeah. Next, I'm so weak. Next time, no fear. I will go direct. Okay, and here I need to provide a token. So remember the token we had in the beginning. Okay, it's asked to provide it again. So let's see. There is a command line for that. Okay, I don't know. I don't need to be clever. I just use a command line. So there is a command line in the CLI to show your token. So I use that. So pretty useful CLI. And here is the mapping. And the mapping is attribute of the message to column of the table. And again, I will probably just copy pasting. Here it is. That's my mapping. So here you see that the column name equal value dot attribute name. Because in a Pulsar message, not only you have the value, but also the header and properties. So you can add some metadata and do some logic based on those metadata. Okay, and I think, that's it. Look at that. I don't even need to look at my tutorial. It's so natural. Okay, so now it's initializing. It will take about a minute, I think, to move to running state. And look at that.
It'll take just a minute. That sync, it actually, the sync is a function. It's a Pulsar function, but it's been pre-configured, pre-wired up in Astra Streaming for you. And that's why there was that drop-down list of all the different sync types. Any ones that you choose from there, we have pre-built in the environment to make it always available. Just give me the parameters and we'll run it. We'll take care of running that. It's actually a function under the covers. So all of that availability and everything that I was talking about with functions applies to your sinks and sources as well. And then Astra Streaming adds a little bit of value there in managing all that.
Yep, correct. Okay, so let's see.
Yeah, I don't remember if that thing will change to green when it's good.
It should move to running. Yeah, it will move to green running. Right. I don't know if it's automatic, but
you can actually, if you click on the sync name and you scroll down to the bottom, you can watch it deploy.
Oh yeah.
And so if you refresh every once in a while, those are the Pulsar logs. Like that is actually the sync deploying.
Okay. Oh, right, but as of now, it's just showing some
It's
fade stuff. So you know, now I'm getting suspicious that I provided the proper token or not.
if you refresh the top right gray bar there, the little arrows. No, the in that terminal window
Yes,
down there in the on the right of that gray bar.
on the right of the. Oh yeah, that.
There's a little
Okay.
there's yeah, refresh that every once in a while because it's
Oh,
not gonna.
oh, I really need to get that. Blah blah blah. I think it's back
There you
to
go.
info.
Yeah,
So
it's good.
yeah, it took its time, but now it's running. So now moment of trush. And if you're still listening at us, that will be your homework. So that command, okay, is your homework. If you are able to show me the table with stuff inside the table, you're done. That means you did the full. Look at that. You did the full training, the full labs, and it's working like that. And yeah, do not copy paste your YouTube video right now because I know what is there. And of course, it's randomized. So hopefully, you will not get the same as me. And that's the beauty of that. Okay. So, but you know, your homework is that, and it's really a Google form with a couple of questions. Yeah, I already responded. A couple of questions about the session today, and just uploading these screenshots stating that you have completed that. Give us a couple of days, maybe a week, and we will redeem you that badges. Okay. Woof! What a ride. You know what? I did not expect
Wow,
at all that we will be on time.
we're 7 minutes ahead.
And look at that. Oh, we still have the game to play. Okay, so you know that's
Uh,
serious as well. We need to play the game before wrapping up. But hey, I think I don't have a lot of questions for the game. So you know, and we don't have so many people left. So you have a pretty decent chance to win some swag right now. Okay, so let's move to swag mode. Okay, Menti, let's go. Quiz regarding Pulsar. Let's see if I'm able to put a smile on David's face with my stupid questions.
I haven't seen this quiz, so you all know. So this is going to be good.
Okay, okay. Do you want to play? Oh, geez, only five, six. Okay, I will wait a bit. I mean, 6 minutes is so 5 questions, 6 minutes. Why not enough? Okay, so housekeeping. Look at your phone because YouTube does have some latency, and the faster you respond, the more chance you have to win. So answer fast with the correct answer, and yeah, let's see who was paying attention. Let's see if we was a great teacher or not. You know, sometimes it's like that. Okay, 5 minutes in, I see eight people. So yeah, let's nine. I saw 10 at the moment, but okay, let's wait for 10 and then go. So again, menti.com, using the code here, we can provide back the
I looked.
chat.
I was looking on my phone to log into Menti because I wanted to see the questions.
You will see the question on my screen as well.
Okay.
Okay. All right. Okay. So let's go. You know, I don't want you to wait too much. Again, people are coming from very eastern. And for fast to get more points, what is not a Pulsar component? A broker, a producer, a scheduler, a consumer, or a bookie? Which one has not been announced? Thank you, New Dash D, but boom, time out. Yeah, indeed. So the broker was broker and bookie was shown in the design slides in the beginning, but indeed we did not talk about the scheduler at all. Okay,
That's cool.
so let's see. It was not a funny question. Okay, it was a serious question. Wow, if only 4 people play, man, everybody will win. We will just have one winner, one loser, and 3 winners. Okay, next question. Get ready. What are lightweight processes in Pulsar code? Are they Pulsar stream, Pulsar function, Pulsar sinks, or tesseract? Yeah, lightweight process. This is exactly how they are defined on the Pulsar website. Yeah, it was called Pulsar functions that are lightweight process in Pulsar. Pulsar streams, that was, you know, like a trick like Kafka streams. No, it's Pulsar functions.
It's a good one.
Yeah, see? And
pretty close.
Yeah. So Arnab moved to second place. Pritam, Arnab, Florian M. Our 3 leading question 3. Which NoSQL database run in AstraDB? Okay, speed question. Redis, Mongo, Elastic, Cassandra, NoDB.
Everybody should get this.
You know, sometimes it's speed question. Oh man, no, it was really Cassandra.
I think whoever answered Mongo is just trolling you, Cedric.
Yeah, probably. Yeah. That must be that.
Wow.
And look at that. Santiago was
up.
fourth, but now he's in the 3 winners. So let's see. Only what, 2 questions left? So question 4. Pulsar IOs copy message from topics to sources, to stars, to sinks, or to something.
Ooh, that's a tough one.
I mean, we saw the pie, you know.
Yeah. Think about the flow of messages.
Yes.
There you go.
Yeah. Stars. Maybe
from
it was
topic.
Yeah, from topic up to something.
That's the thing, not to topic.
Yep. I mean, I need a little bit of spice, right? Okay.
That was good. That could be a shakeup.
Yeah. Okay. Right. Okay. Last question. Speed question. How can you interact with AstraDB?
That's a good question.
With Cassandra Query Language, with the REST API, with document-oriented API, or all of the above? And all the answers were correct.
There are no wrong answers.
Okay, so it was a speed question. Any stuff you picked would have been the correct one, but all of the above is obviously the best of the 4. Okay, so let's see who are our 3 winners today. And Mohammed, get the last question. But okay, so Arnab, Shunduri, congratulations, and the 2. So Pritam and Santiago.
Right.
Do a screenshot of your phone or laptop right now just to prove that you have win today. I will keep these stuff open for any feedback or things we should improve. For the winners, this is the form you need to fill, dtsx.io, so workshop swag. And there you will be routed to a swag store when you can pick the swag you want. So tell your friend, we are there every week and we redeem swags like that every week. Okay, all right. So we almost end of the session. So if you still have questions to us, move to Discord. This is the link. We will be happy to answer your question there. For the homeworks, there is no limit of time. Obviously, this week we will be more focused on the answer, but if it's later because you're watching a recording, no problem. We will get a review of your session for your work to get your badge. So if you stay with us up to the end, maybe you could like the session, subscribe to the YouTube channel, not to miss any content we provide. Not only we do these great and interactive live workshops every week, but also we are releasing quite a lot of technical topic, especially on Pulsar with these 5 Minute with Pulsar series containing dozens of videos already.
Yeah, that is it's a playlist on the DataStax Devs YouTube channel called 5 Minutes About Pulsar, and you could subscribe to that, like that. Just a bunch of 5-minute kind of bite-sized ideas and things. Some of them are deep into Pulsar, some of them are not deep. The basics in Pulsar, which is kind of an easy way to get going and understand different concepts.
All right. Okay. So, that's the end for today. Again, please subscribe if you want to. It has been a pleasure to be your host for today. Hope you learned something. We had the proper pace. And, if you have any question, please reach out to us as usual.
Great job, Cedric. Thank you. That was awesome.
Great jobs to you. It was a pleasure as usual. And for everybody else, hope to see you next week.
All right.
Bye.
Thanks, everybody.